How's it going, everybody? Today I'm going to be teaching you how to design an off-grid power system completely from scratch. So normally when I'm designing an electrical system, I like to think in terms of inputs and outputs. Those are usually pretty well defined. So in the case of a van life application, a van conversion, what are going to be our inputs? Well, we're getting power from the sun that's coming from a solar panel, okay? So solar panel is generating power. Well, what do we want to do with this power? We want to power things. What do we want to power? Again, specific to the van life, we might want to power lights, a refrigerator, a faucet, like the water pump to your faucet, maybe a laptop charger, okay? So those are our outputs. So our input, energy from the sun, output, the consumers of that energy. Okay, so let me just draw that out really quick. Inputs. Okay, so to keep it simple, I just drew a light bulb for the outputs. And there's our solar panel on the input. Okay, so now how do we connect these two components together? Well, we could just draw a line straight from the panel to the light bulb, but there's some problems with that. What if it's a cloudy day, we're not getting any sun, then we're not going to be able to power our light. Or even more importantly, it's night and we want to power lights on at night, right? It's going to do us no good if we can only run the system during the day. So we need a way of harnessing this energy that's being produced by the solar panel and storing it for later, okay? And that's where batteries come into play. So a battery is going to be able to store the energy generated by the panel when we're not using it, and then be able to provide that same energy to the consumers when we want to use it. So we just have to figure out now, how do we connect the solar panel to the battery? Unfortunately, we can't just go directly because solar panels operate at many different voltages, and batteries are very particular of what voltage they work at. When you're charging a battery, it has to be a very specific voltage. Otherwise, if it gets out of the range, you can damage the battery, and even worse, cause a hazard, a potential fire. Or specifically in the case with lithium, they can get into a thermal runaway event, and that's going to cause a fire, which obviously isn't any good. So we need a way of regulating that power from the solar panels to the batteries, okay? So there's this device on the market, it's called a charge controller. So again, the charge controller is going to regulate the power, the voltages from the solar panel to voltages that the battery likes and can work with. And there's really only two types of charge controllers on the market. There's a PWM, which is pulse width modulation, and MPPT, which is maximum power point transfer. So I'm not going to go into the details of the differences. Basically what you need to know is that PWM is going to be cheaper, but not as efficient at converting the energy. And then maximum power point transfer controllers, as the name implies, is going to be better at actually converting that energy, getting maximum power from the panel into the battery. It's going to be a little bit more expensive though. But in the case of, if you're off grid and you're relying on this power day in and day out, you probably want to go with an MPPT controller, because that's going to be the most efficient, conversion of energy. So let's assume that's an MPPT controller. Okay, so we're getting power from the sun, this panel. It's charging our battery, and this part of the system is happy. Now, how do we go about powering our loads, the consumers? Well, the best way to do that is to add a fuse block between your battery and your loads. Without this fuse block, you could have another potentially hazardous situation. So let's say that for whatever reason your device fails, the light fails, and it's drawing a bunch of current, like it's shorted to ground, and it's just going to keep asking for more and more current from the battery. If there's no fuse there, the batteries are just going to keep sourcing this current, and it's going to start heating up the cable. And once you start heating up the cable, it's going to start to melt it, and then you have now a really hot piece of object, metal, that could, you know, catch fire on your blankets or something, right? So we obviously want to avoid that situation, and how we do this is with a fuse block, or fuses, inline fuses between the battery and your consumers. Okay, so now I started with a really simple example of a light bulb, and in this case it's a DC direct current light bulb. So right now the system is only capable of powering direct current DC loads, but what if we want to power you know, our laptop charger? You know, normally you would take that and plug it into your outlet at your house, which is providing AC power, alternating current. So we need a way of converting DC to AC, and you do that with what's called an inverter. So the inverter again is taking DC power and converting it to AC. So now we can power our laptop. Okay, so this system's now looking pretty good. There is a flaw still. Like I mentioned earlier, if it's a cloudy day right now, we're not going to be charging that battery. So we need an additional source of energy. In the case of a sunny day, you know, you don't want to go without power. So a way of doing this is taking power from your vehicle's alternator, which is, you know, essentially it's just a generator, which is converting mechanical energy into electrical energy. And so we'll take that energy and charge our battery with it, and that's how vehicles work. Obviously, that's how the alternator is supposed to work. The only problem is, if we're using a lithium battery, the chemistry lithium versus what's typically found in your vehicle is like a lead acid, then those two battery chemistries, they work at different voltages. So you can't just tie your alternator, you can't just tie it directly to the battery. It's the same very similar situation with the panel generating different voltages that the battery likes. So we're gonna need another charge controller in line. But this can be a very simple, just DC-DC converter. So it's gonna convert the DC power from your alternator and convert it to a different voltage that the battery likes. Okay, awesome. And so again, a way to think about this whole system is to think about your battery as a bank, an energy bank. So you want to design it so that your solar panels are inputting as much energy or money you can consider into the bank at a higher or equal rate than you are taking money or energy from the bank. So so basically we have all the components, but now we need to figure out how to size each specific device. And the way to do this is to define the total watt hours that you're going to be using in a given day. So, and I'll probably have a link in the description with a link to be able to do this. It's just a table where you're going to list all your different consumers, the power that they operate, and how long you expect to use them in a given day. And basically once you sum all of these up, it's going to give you a watt hour number. And so basically you want to design the system so that the solar panel is giving you as much watt hours power input to the battery as you are consuming. So what's next? No, it's okay. Okay, yeah, so you want to be inputting as much energy into the system as you are consuming. So again, you define all your outputs, all the consumers, you put them in a list. You say, hey, it's going to operate for this amount of time. Like my lights, okay, they're only going to be on at night for a few hours. And my lights draw 1 amp of current. So in 5 hours, if I only use it for 5 hours, and that's 1 amp, that's 5 amp hours in total. So then all you would have to do is design the battery and the panel to provide that amount of energy in a given day. And then once you figure that out, the last part is just speccing the cable sizing, and that's really easy. All you need to know is the voltage of the device, the current, and the length of the cable. So you have a general idea of where you're going to be putting these components in the van or wherever, and so you know the cable length, and you also know what the device draws and what its power is, the voltage and the current. And so you go online and there's a calculator that's going to tell you, hey, you input those 3 things, the voltage, the current, and the cable length, and it's going to tell you use this size cable. So again, to recap, it's pretty simple to design the system. You just define your inputs and your outputs. In this case, we have a solar panel and the alternator as our inputs. The outputs are all the consumers, the loads that we want to be powering. Once you've defined those, then you define the total watt hour per day of your consumers, and that's going to give you how you size all the individual components, how you size the solar panel, the battery, and all this. And maybe in a separate video I'll go into more detail. But for now, that can get you going on a very basic design. Guys, I hope you found this video useful. As you can see, it's not that hard to design a power system, an off-grid power system. Let me know in the comments if you want videos on anything specific, or if I didn't mention something. But anyways, that's it for today. Until next time.